Since the dawn of time, humans have looked up at the night sky and wondered, are we alone? The stars above are not just distant lights. They are portals to the unknown. Black holes. From the dawn of time, humanity has gazed at the sky with questions that seemed impossible to answer. Among all the wonders of the universe, there is one phenomenon that inspires both fear and fascination: black holes. Mysterious, invisible, and colossal. Guardians of secrets that defy the very laws of physics. Today, we will dive into these cosmic titans, exploring their enigmas and uncovering how science is only beginning to understand their true nature. Imagine a place where gravity is so intense that nothing, not even light, can escape. A place where time and space bend, and where the concept of reality, as we know it, ceases to exist. That, my friends, is a black hole. What is a black hole? A black hole is not a solid object, nor an ordinary star. It is a region of space where gravity is so intense that it traps everything that comes near. They form when a massive star reaches the end of its life and collapses upon itself, concentrating an enormous mass into a tiny space. To better understand it, imagine a stretched out sheet. Place a heavy ball in the center and watch how the fabric bends. That curvature represents how gravity distorts space-time around a black hole. Any object nearby, even light, becomes trapped in this distortion, making escape impossible. Black holes are invisible to the naked eye, but we can detect them by observing their effects on the environment. For example, stars orbiting around an empty point, or disks of gas emitting intense radiation as they are swallowed. If a human were to get too close to a black hole, they would experience a phenomenon called spaghettification. The gravitational forces would stretch the body extremely, elongating it from head to toe. From the perspective of the falling person, the journey continues endlessly, passing through a bizarre landscape of warped space. But to a distant observer, the traveler would seem to slow down and freeze in time at the edge of the event horizon. This duality shows how black holes challenge our perception of time and space, turning into natural laboratories for studying the limits of physics. Types of black holes. There are several types of black holes, each with unique characteristics. First, stellar black holes, which form from the death of very massive stars. Their size ranges from a few to dozens of times the mass of the Sun. They are the most common in our galaxy and the most studied so far. Then, supermassive black holes, which reside at the centers of almost all galaxies, including our Milky Way. They can have masses equivalent to millions or even billions of suns. Their influence is so great that they shape the formation and evolution of the galaxy around them. There are also intermediate black holes, less known and harder to detect. They are the missing links between stellar and supermassive black holes, and studying them may reveal how these cosmic giants grow. Finally, primordial black holes, still theoretical, that could have formed in the very first moments after the Big Bang. Although their existence has not yet been confirmed, they could help us understand the early structure of the universe and the nature of dark matter. The point of no return. Every black hole has an invisible boundary called the event horizon. It is the line beyond which nothing can escape. To a distant observer, any object approaching appears to slow down, as if time itself were frozen. But for the one falling in, the journey continues inexorably into the depths of the black hole. This boundary not only marks the point of no return, but it also challenges our understanding of physics. The laws that govern our universe stop behaving predictably. Time distorts, space curves, and concepts such as up or down lose meaning. Modern physics, thanks to Einstein's theory of relativity, allows us to model these extreme regions. However, the singularity at the center of a black hole, where density becomes infinite, remains an absolute mystery. Mysteries and paradoxes. One of the greatest enigmas of black holes is the information paradox. According to quantum mechanics, information can never be destroyed. Yet when something crosses the event horizon, it seems to vanish forever. Is it destroyed or preserved in ways we do not yet understand? Stephen Hawking proposed that black holes emit a faint radiation known as Hawking radiation, and that over time they could completely evaporate. This raises new questions. If they disappear, what happens to all the information they trapped for millions of years? Some scientists also speculate that black holes might contain portals to other universes. While still only a theory, these ideas force us to rethink the limits of reality and the very nature of the cosmos. Famous black holes of the universe. Among the most studied black holes is Sagittarius, a star located at the heart of the Milky Way. Its mass is equivalent to about 4 million suns, influencing the movement of all nearby stars. Another giant is Ent3-r the first black hole ever photographed in 2019 by the Event Horizon telescope. Its image revealed a dark shadow surrounded by a bright ring, confirming decades of theories. Cygnus X1 is a stellar black hole and one of the first candidates discovered through X-rays. Its study helped astronomers better understand how these extreme objects work. And beyond, there are black holes wandering silently through space, unseen, quiet, waiting to be discovered by future generations of telescopes and sensors. The future of black hole research. Modern astronomy continues to unravel their secrets. The Event Horizon telescope and other observatories allow scientists to capture increasingly precise images, study gravitational waves, and understand the dynamics of these extreme regions. The future promises even more astonishing discoveries: black hole mergers, measurements of their spin, and studies of how they shape the formation of entire galaxies. Each discovery brings us closer to answering fundamental questions. What happened at the beginning of the universe? What will happen in the future? Black holes teach us humility and wonder. They remind us that, despite the progress of science, the cosmos will always hold mysteries greater than ourselves. And perhaps, in our quest to understand them, we may also discover more about who we are. If you want to keep exploring the mysteries of the universe and uncover secrets that science is only beginning to grasp, subscribe to Ent3-r the Void and join us on this infinite journey. The cosmos is watching, and are you ready to stare into the abyss?